Welcome and study with Tanzania Institute of Education.
A plane figure is any two-dimensional shape, like these. In this lesson, we'll be working on finding the area of plane figures. When you are asked to calculate the perimeter of a plane figure, like this isosceles triangle, for example, it means that you need to find the total length of its outside edge by adding together the lengths of each of its sides. Here, the total Fidel has walked is 28 meters. So to find the perimeter of a plane figure, we simply add up the lengths of all its sides. But how do we find the area of plane figures? Let's start by revising how to calculate the area of different triangles. The area of a right-angled triangle is calculated by multiplying 1/2 by the base and the height. So if this triangle had the following dimensions, we'd substitute these values into our formula. Area equals 1/2 times base times height, making it 1/2 times 10 times 8. And the area of this triangle is 40 centimeters squared. This formula stays the same for all triangles. However, to make it work for triangles which are not right-angled, like this isosceles triangle, you'll first need to find the triangle's perpendicular height. This can usually be done by using the Theorem of Pythagoras. b squared plus h squared equals x squared. Let's see how this works. If both these slanted sides were 5 centimeters, the base of the triangle, BC, equal to 8 centimeters, and each of these little b's, 4 centimeters, we'd have enough values to find our unknown length, h. b is 4, x is 5. We rearrange the formula so h squared is on the left-hand side. And we end up with h squared is equal to 5 squared minus 4 squared, or 25 minus 16. So h squared is 9, and therefore h is equal to 3. Now we have the perpendicular height, we can go back to using the formula for finding a triangle's area. The area we're looking for is equal to 1/2 times 8 times 3. So the area of the triangle is 12 centimeters squared. These same rules can be applied to calculating the area of an equilateral triangle. First, find the perpendicular height of the triangle using Pythagoras. Here, our sides are all equal to 10 centimeters, so the base we need to use for Pythagoras is 5 centimeters and the hypotenuse 10 centimeters. We substitute in these values, make h squared the subject and solve for h, which we find is the square root of 75. Next, we substitute this into our formula for finding the area of the triangle. Area of a triangle equals 1/2 times base times perpendicular height, which is 1/2 times 10 times the square root of 75. The area for this triangle is 5 root 75. Now we've covered calculating areas of triangles, let's go over how to do it for other plane figures. Because a square has 4 equal sides, to find its area, you simply multiply any 2 sides together, or even one side by itself. If this square has sides that are 10 meters each, its area will equal 100 meters squared. The area of a rectangle can be found by multiplying its length by its width. In this example, the rectangle has a length of 15 meters and a width of 10 meters, so it has an area of 150 meters squared. A rhombus is like a square that has been pushed and has 4 equal sides. However, this means that angles are not equal to 90 degrees, so we can't use the formula for the area of a square to find the area of a rhombus. Instead, we use the formula area equals b times h, where b is the length of any of the rhombus's 4 sides and h is the perpendicular height of the rhombus. If you are not given a perpendicular height, you'll need to find it using Pythagoras, as you would with triangles. This rhombus has sides equal to 8 centimeters and a perpendicular height of 7.6 centimeters, so it has an area of 60.8 centimeters squared. Now we get to our last 2 plane figures. To find the area of a parallelogram, you use the same formula as for a rhombus. Find the perpendicular height, using Pythagoras if necessary, and then multiply the base by this height. This parallelogram has a base that is 13 centimeters long and a perpendicular height of 4 centimeters, so its area is 13 times 4 equals 52 centimeters squared. For a trapezium, the formula for finding its area is area equals 1/2 times h times a plus b. A and b are the lengths of the parallel sides of the trapezium, a the shorter side and b the longer. If the perpendicular height for this trapezium were 4 centimeters, and the lengths of our parallel sides a 5 centimeters and b 8 centimeters, area equals 1/2 times h times a plus b. So we would have 1/2 times 4 times 5 plus 8 in brackets. We make sure to add up the values in brackets before multiplying, and the area of this trapezium is 26 centimeters squared. So far, we've been saying that we need the perpendicular height of a triangle to find its area. But what happens if we can't find the perpendicular height of a triangle? Around 2,000 years ago in Egypt, a very smart man who we know as Hero, or Heron, of Alexandria, came up with this formula, which uses only the lengths of the 3 sides of a triangle to find its area. Scary looking, but really quite simple once you've understood it. Let's break it down. To find the area of a triangle using Heron's formula, we need to know 4 things. The first 3 are the lengths of the 3 sides of the triangle, A, B, and C. The fourth is something called the semi-perimeter, which we call S. What's a semi-perimeter? Just as a semicircle is half of a circle, a semi-perimeter means half a perimeter. To find it, we just have to add together A, B, and C to find the perimeter, and then divide this by 2. Okay, let's work out the area of this triangle using Heron's formula. The area of a triangle equals the square root of S times S minus A times S minus B times S minus C. We have A, B, and C. These are our 3 sides, 8, 5, and 7. You can use these in any order. We don't know what S is, but we can calculate it by finding the perimeter and then dividing this by 2. 8 plus 5 plus 7 is 20. Divided by 2 is 10. So, S equals 10. Now we have all the variables needed to find the area. We put them into the equation and find that the area of triangle ABC is 17.32 units squared. Simple, huh? The wonderful thing about Heron's formula is that it doesn't just help us to find the areas of triangles. It can also help us to find the area of many quadrilaterals because quadrilaterals can be divided up into triangles. And that's pretty cool.